Today we are going to learn about increasing and decreasing functions. If we look at the first graph, we see that x would be greater than or equal to -2, and x would be less than or equal to 1. The circles are colored in. Those are closed circles. That means that it includes the number -2, it includes the number 1, and the line is telling us that everything in between. The type of interval for this graph would be a closed because of the circles. Would be a closed interval. And then over here, we see that we have open circles at 1 and 4. It's going to be every number after 1 and before 4. The open circles do not include 1 and 4. This would be an open interval. In Algebra 2, we would have written a compound inequality that says x is greater than or equal to -2, and x would be less than or equal to 1. In pre-calculus, we've learned to write it in interval notation. It does include -2 because of the closed circle. That would be a square bracket. We're going from -2 to 1, and that would be a square bracket, again, because it's a colored in circle. On this graph, we would say that x is greater than 1, but does not include 1. It's greater than 1 because of the open circle, and x would be less than 4 because of the open circle, and it does not include 4. In pre-calculus, we would write that as a rounded bracket to show that it does not include 1. We're going from 1 to 4. The definition of an increasing function is a function is increasing if and only if for any 2 points, x1 and x2, they are an element of the reals, and x1 is less than x2. This implies that f of x of 1 is less than f of x of 2. First y coordinate is less than the second y coordinate. F of x, remember, stands for y. So when the function is increasing, you will see here it's increasing. If I just pick 2 points on this function, x1 is less than x2. Well, here's x1 at -1, and here's x2 at 1. The first x coordinate is less than the second x coordinate. This implies that f of x of 1 is less than f of x of 2. That means that the first y coordinate is going to be less than the second y coordinate. So if I look at the y coordinate, -1 is less than +1, the y coordinate. That makes it an increasing function. The definition of a decreasing function: a function is decreasing if and only if for any 2 points, x1 and x2 have to be an element of the reals, and x1 is less than x2, which implies that f of x of 1 is greater than f of x of 2. Again, if I look at any 2 points, x1 is -1, x2 is 1. The first coordinate is less than the second coordinate, but my y1 is going to be greater than my y2. My y1 is here. It is 1, and my y2 is here, is -1. So the y1 is greater than the y2. The next definition would be strictly monotonic functions: a function that is increasing over its entire domain or one that is decreasing over the entire domain would be a strictly monotonic function. Starting from left to right, what's happening to this function? It is decreasing. Over the entire domain, it's decreasing. This would be strictly monotonic. The second function, as I work from the left, I see that the function is decreasing. It stops here, and then it begins to increase. This is not strictly monotonic. You will have to describe functions in intervals, like the red is decreasing from -infinity to 0. And then the blue part of the parabola is increasing from 0 to +infinity. And so in the homework, you will have to describe functions in this way. The first graph shows that it is decreasing over the entire domain. The second graph shows a quadratic that is decreasing in the interval from negative infinity to 0, and then it's increasing on the interval from 0 to positive infinity. It's increasing. A function is said to be one-to-one if every x term is paired with exactly one y term. Every x term goes to one y term. That would be one-to-one. How do we know if it's going to be one-to-one? We would do a horizontal line test. And remember, the vertical line test was about whether or not it was a function. Now we have two different types of tests. One to test for one-to-one and one to test if it's a function. The first function shows a circle mapping, and we can see that we have two x values going to two different y values. This is not a function because you have repeating x values. I would also be able to see that it's not a function by doing a vertical line test. The first one is not a function, it fails the vertical line test. The second function, we see we have no repeating x values, but we do have the x values going to the same y values. What does that mean for our picture? That means when I do a horizontal line test, it is not one-to-one. This is a function because there are no repeating x values. I could do a vertical line test on this and it would pass, but it fails the horizontal line test. This function would be said to be a function, but it is not one-to-one. It fails the horizontal line test. The last function, you have every x value going to a different y value. If I was going to do a horizontal line test on this function, it would pass. If I did a vertical line test on this function, it would also pass. This last function is said to be one-to-one, and it's a function, a one-to-one function. It passes the vertical and the horizontal line test. Example 1, write an interval for the following graphs. X is greater than -1. It does not include -1. It does not include -1, and it's going to positive infinity. Interval notation. Problem B, X is less than or equal to -5. It does include -5 because of the colored in circle. We always do interval notation from least to greatest. Negative infinity all the way to -5. Square bracket for -5, rounded bracket for negative infinity. Problem C, we are going from -1 to 4 only, and it includes -1 and 4. We are going from -1 to 4. The next one will have to be talked about in two separate intervals. Negative infinity to 2, negative infinity to 2, and 1 to positive infinity. Does not include 1. Rounded brackets for infinity and negative infinity. The last example, we are going from -3 to 7. Starting at -3 and going to 7.